The number of network segments is 2 to the 21st power. Network bits are now 24 bits. Class C addresses are fixed with the first 3 digits. Everything is variable. So the number of network segments is 2 to the 21st power. The number of available hosts per network segment is 2 to the 8th power minus 2. Then it works out to be 254. This number looks familiar. You will come into contact with it often in the future. So let's discuss a question now. The number of hosts on this network segment. Why subtract 2? Okay. It's about one of our rules. I'll give you an example of an address. 192.168.1.1. Suppose such an address. 24-bit mask. In fact, it is 3 255 and 10. Then let's calculate. 192 is 110000000. 168 is 0.10101000. Then 0.10000000. Last is 0.00010000. This is its IP address. Subnet masks are simple. Except the last. All the rest are 1. Okay. Above is the IP. Below is the mask. Now the mask is 0. The corresponding part is the host bit. When I put the host bits corresponding to these bits, when all are set to 0, it represents a network address of this network segment. These are the network bits. These are all immutable values. Then put the latter. All take the value 0. When I mask these host bits to 0, when all values are 0, this represents the network address of a network segment. Notice. Also called network number. It has a role. It can represent all addresses in this network segment. You will be in the routing table. See this address format. That is to say, it will appear in the routing table as a representation. There is no way to configure. For example, this is a network address. 192.168.1.0. Then copy it. See this section marked in yellow. That is, set all host bits to 1. The above is all set to 0. The following is all set to 1. At this point the number here should be 192.168.1.255. Look now. It and the above number. It seems that there is a difference. Because the last 8 bits are all 1. So this is 1.255. Such an address is called a broadcast address. Then, for a network segment, we will send broadcast messages later. In the future, your destination address is a broadcast address. Such an address is used within this network. That is, on a network segment, one address for all hosts to communicate with. If the destination address is such an address, it represents a broadcast message. It cannot be said that it is the destination address of this broadcast. So, in each network segment, these 2 addresses are quite special. They are not allowed to be configured on the device interface. When the host bits are all 0, this happens to be the smallest address on a network segment. When the host bits are all 1, this happens to be the largest address in the entire network segment. Minimum and maximum addresses in each network segment cannot be configured on the interface. Now let's summarize this table. Everyone can observe. For ABC 3 addresses, they have a mutual law. As an address, this is the least. Only 126 available. Suppose 126. High number of available hosts per network segment. Because of the lack of network bits. Large host. We said before, hosts on the same network segment can communicate directly. So you will find more than 16 million hosts can be added to a network segment. Can communicate directly. One network segment has so many hosts that can be configured. Class B is relatively average. Let's look at Class C. The network segment can be divided into many. However, the number of host bits per network segment is relatively small. So we can draw a rule from this. For equipment, fewer network bits. The smaller the number of network segments that can be allocated in a network segment. Because the network bits are only 8 bits. But now only 100 plus can be allocated. The corresponding number of host bits can be more. The number of available network segments within a network segment is less. The more hosts, the more. The corresponding addresses allocated in the host can be more. So you will find it's a peer-to-peer relationship. The number of Class A address network segments is small. But the number of hosts in a network segment is large. A large number of Class C address network segments. But the number of hosts will be relatively less. So it is for different companies. That is, I said before, small businesses don't have that many people. So the general Class C address is done. There are only a few dozen devices. You don't need to spend such a large network segment for it. For medium-sized companies, generally a Class B address is sufficient. But sometimes Class A is also used. Because if it is used as a private network address, divide by oneself. It's just a management issue. Also I said, the network address appears in the routing table. I will give you a simple example. For example, 192.168.1.1. You see it's only fixed up to here. That is, it belongs to the 0.0 segment. Then the configurable is from 0.1 to 0.254. In theory. For example, I am now drawing a device. Router. We haven't learned yet. Just tell everyone. Many interfaces connect different places. A data comes in from this interface. Suppose you want to go to 192.168.1.2. I'll go after that. 3. Go 0.4. Go 0.5. All the way up to 0.254. There will be a table in the router called the routing table. That is to say, a data comes in. I need to look up the table to forward. This is the interface 1 of my device. If the data comes from 0.3, forwarded from interface 1. So 0.3 corresponds to the interface 1 of the device. In the future, everyone will learn about routers. Each interface is actually a broadcast domain. Can be understood in a narrow sense as it's on a network segment. If the data goes to 0.4, I also send from port 1. Data goes 0.5. I also send from port 1. These messages are stored in the routing table of the router. Then, for the same, you may find it a little cumbersome. As a network segment, let's say now from 0.1 to 250. Leave a few. Because the interface still has an address. Let's say all these 200 plus addresses. All sent from port 1. Is it necessary to write more than 200 addresses in the routing table? Write more than 200 correspondences. This address is the same interface. That address is the same interface. Actually, 190